So we'll be talking about the power electronics. So can anyone tell me like what is electronics and what is the difference between electronics and power electronics? Can anyone from the audience participant can tell me?
Sir, like I wanted to tell you.
Yeah, you can say.
Yes. So in power electronics, usually we deal with higher voltages, with the power devices, and in only electronics we deal with lower voltages, like low voltage devices. For suppose in power electronics we deal with the IGBT, silicon carbide, which is rated for the much voltage and current.
Yeah. Yeah, so you are right. So basically, by adding the power to this electronics, it means that we are dealing here with kilowatts, like higher voltage level. Now, when we talk about the electric vehicles, so in electric vehicles, we also use voice not wait.
So in electric vehicles, we use lots of power converters also, which are present in the electric vehicles. Talking about the battery to motor connection, to motor to the auxiliary battery connections, auxiliary components which are connected to the present into the electric vehicle. So there are lots of power electronics things which are available in our surroundings, also into the electric vehicles. So we'll try to demonstrate few things onto the MATLAB software, like how we design the converters, what are the methods which we use to designing of the power electronics converters, and also how we steps, what different formulas which we requires, what are the basic calculations we do for calculating the component. So today we'll talk about the basic introduction to the power electronics. Then we'll talk about the power electronics which is presented in the electric vehicle and the future trends and development. And also we'll go on to the MATLAB for designing this. For designing this, designing a MATLAB converter, power converter. Basically, it will be a buck converter. So we'll go to design that part. So first of all, onto the screen, we'll talk about the applications of the power electronics. So can anyone tell me example of power electronics like in our day-to-day life? Can anyone tell me?
Ceiling fan regulator.
Yes.
In our day-to-day life, whatever the equipment we are using electronics, which is going to be operating with high, particularly of normal single phase 240 volts or a 3-phase with a small size, then all those equipments we are deal with the power electronics.
Okay, so yeah, you are right. Like about the power electronics, I'm asking any examples which you see, in which you are using power electronics in your day-to-day life.
Mobile chargers.
Yes.
Mobile chargers.
The mobile charger, yeah.
Inverters are used in UPS, sir.
UPS also. So this more.
Also in our air conditioners, ACs, we can use the inverters.
Motherboard.
Yes, for more example.
The induction heating. We also use the chopper.
Chopper, yeah. Where?
Switching device of e-rickshaw.
Switching device of e-rickshaw.
E-rickshaw, yes, sir.
So can you please elaborate this switching device of e-rickshaw?
Sir, e-rickshaw is a DC to DC converter that put the voltage down. Put the voltage at desired level of voltage,
E-rickshaw.
Like,
E-rickshaw.
yes, sir, e-rickshaw.
So basically,
E-rickshaw also the charger of e-rickshaw.
e-rickshaw converts desired level. I think the right answer will be chopper.
Yes,
So
sir.
when someone said about chopper,
Yes, sir.
BFD, voltage, frequency drive. Yeah, you can say.
Yes.
So someone said about the chopper. Can anyone tell me like where we use chopper?
So basically, choppers are, I think it's a MOSFET, so it's convert input DC into a variable DC supply. So it's just
So basically, one thing is there that this inverter, rectifier, chopper, all these things are combination of switches. Like these switches perform switching at a particular instant or according to the circuit configuration, and because of that switching, we get the required output. Okay, so these are the onto the screen we can see about the power electronic applications. So depending upon the power level, so you can see here the power level like from 1 watt to 10 watt. It are the battery operated equipment, the flashes, 10 watt to 100 watt. We can see satellite power system, typical offline flyback supplies. Then we talk about the power level like the computer power supply. So you can say that the power requirement of that is 100 to 1 kilowatt. When we talk about the hot tub or the like heater, it is about 1 to 10 kilowatt. And when we come to this 10 to 100 kilowatt, then the electric vehicles will be coming into the scenario, because whenever we talk about the electric vehicles, the battery pack which are present into the four-wheeler, they are about 40 watt, 40 kilowatt, 50 kilowatt, 60 kilowatt. It's like depending upon the range as well as the specification of that vehicle, electric vehicle, and the battery pack depends. Then we come to the eddy current braking. Then we have buses. So buses are like because of the space, lots of space available under the buses, and we can go to 100 kilowatt to 1 megawatt power level. On this magnetic aircraft launch, so this here the power level is 10 megawatt to 100 megawatt. So this megawatt, like the switching, how the power conversion will be happening. So all these things will have the power devices which are present onto it, and because of that power devices switchings, we are getting the desired output. So this is about the few applications of the power electronics. So now let's talk to the electric vehicle. So onto the screen you can see here like an electric vehicle. So this is basically a hybrid electric vehicle. So engine and radiators are also present here. So now you can see here the engine which is connected to a power converter or electric motor here. So there is also a power electronics being used here. Now this is, you can see a battery. So battery basically stores energy into the form of DC. DC energy will be stored into this battery. Yeah, sorry. So battery pack stores energy into the DC form. And if we are using a DC motor, let's suppose we are using a BLDC motor, so there will be no converter. Like if we want to step up or step down the voltage level, DC voltage level, then we will be using a chopper. But when we are using AC motors and we want the power supply from the battery, so can you name that power converter which will convert the DC to AC?
Inverter.
Yes, inverter.
converter.
Yeah, converter, like all the power converters belongs inverter, rectifier, choppers, they are belong to converter itself. I'm asking that particular name of that converter.
Sir, it is inverter. It is called inverter.
Yeah, so DC, basically in our homes, we can see like we have a battery pack, battery and an inverter is there. So what does it do? It simply converts the DC to AC. So stored DC is converted into AC by using an inverter. So the inverter is a power converter, or you can say the converter there. So now if we talk about the charger, so chargers are basically of two types. The first one is the onboard as well as the offboard charger. So basically offboard chargers is the DC type of chargers. When we do the charging from the DC DC chargers, we didn't require a onboard charger. But when we are doing a charger, which charging from the AC supply, then we require a onboard charger. So can you tell me, like, onboard charger is exactly what?
Safe in battery.
Yes.
सेफ इन बैटरी चार्जिंग कंट्रोल भी होता है सेफ इन बैटरी को भी सुरक्षित कर रखता है
My question is,
it's a rectifier.
Yeah, it's a rectifier. So basically, when we are using giving a AC power supply, and we want to convert that AC into DC, so we'll be using a rectifier. So that is onboard charger. So these are the power converter which are being present into the electric vehicles, and also like for driving our electric motor, we require a high power battery. But what about the auxiliary components such as headlight, sound system, and tail light, as well as the indicators? So, and horns also. So what we require a low level of voltage. So how we will be getting that?
12-volt battery, we have to use secondary battery.
So DC to DC converter.
We can use a boost converter.
Yeah.
Or a buck converter.
Boost, no, actually we be using a chopper. So after chopper, it is being configured into three types, or like basically three types. Otherwise, there are cup converters as well as the CP converters. Basically, three types of converters. Choppers are there. So buck boost and as well as the buck boost. So now buck converter, what does it do? Like suppose this battery pack has the voltage level of 300 and our motor requirement is 300. We want to light up our auxiliary components which are having a voltage level of like 12 volt or 20 volt. So a buck converter will what it will be doing? It will be simply converting the 300 volt to 20 or 12 volts. So these are the few like power converters which are being used into the electric vehicles. Now here onto the screen you can see the power electronic devices. So these are the devices. You can see the symbol. So first one is a diode, and this is the BJT, FET, IGBT, SCR, and GTO, TRIAC, and IGC. So these are the different power electronic devices. So depending upon the specification as per the requirement, like if you want to uncontrolled converter, so there will be using a diode. If you want to use the control, so basically we will be using a like CR, GTO, TRIAC, and then DIAC also, the IGBT. So basically here are the different types of switches onto the screen. You can see. Now coming to the next part. The switches which we seen into the previous slide was basically of silicon or germanium, but now from past few years the technology has improved and we are moving towards the silicon carbide and gallium nitride. So what are the benefits of using this type of configurations, like apart from silicon, is that like G and N, they have high frequency levels. So you can see here like the switching frequency or the frequency or the switching frequency of these switches are higher as compared to the silicon based switches. Like if we are using silicon based switches, whether it is MOSFET, so it will be providing near about like 1 megahertz. That when we are using GN, then we will be getting more switching frequency as compared to silicon. And now talking about the power level. So power level is also very requirement. Like if we are moving towards high power, like onto the applications I already discussed about, depending upon the power levels, we have to use the switches. So in electric vehicles, like you can see here, SiC, which is silicon carbide. So these switches has a very high power level. Even they are giving a good switching frequencies as compared to GNA. So these are the basic new technologies like the silicon carbide and GNA. So they are like providing a better switching frequency as compared to silicon and higher power as compared to the silicon. So here are the benefits of like silicon carbide and GNA. Now, we discussed about the switching sequence as well as the switching devices and applications. Now we will be talking about the rectifiers and the inverters and the choppers, because these are the converters which are converting the AC to DC, DC to AC, or DC to DC. So based upon this, we are getting the desired output, like whether it is AC or DC. So first of all, onto the screen, you can see here a rectifier. So rectifier, what does it do?
Conversion of AC to
Convert
DC.
AC to DC.
DC.
Yes, they converts the AC to DC.
DC to DC.
They convert. We'll talk about in more detail, like to the screen. You can see here. Yeah. This is a AC supply. In a rectifier, we have a AC supply. We want to get a DC, which is a direct input. So AC is sinusoidal in nature. You can see here onto the screen. Like we have at the positive side also voltage, and also at the negative side. So we want to convert into the DC. We requires only positive sides. Like how we will be getting that? So just depending upon the switching circuit, like if you see that whenever the switch, so this is a diode. So see the powered semiconductor devices are being used coming into the figure, and this is the load. So we want to know that what is the output. So when we are using the positive half cycle, so this is the positive half cycle. So what will happen when the positive supply will be here and the negative supply will be here? This diode will be forward biased. So when the diode, this is the positive part and this is the negative. When the positive voltage is interface with positive part of the diode and negative is negative, so what will happen? The diode will come into the forward bias condition, and then during that time this switch will be turned on, and at the output we will be getting this voltage, this sinusoidal voltage. Now when we talk about when there is negative cycle, so what will happen into the negative cycle? The switching, the polarity will be changed, and at this end we will be getting negative, and this end will be positive. So at this time, what will happen? The diode will be reverse biased. And during reverse bias, the switch, this circuit will be open circuit, and because of this, there will be no output. So this is this is overall a one time period of the switch, like the supply. You can see from here, like positive half, negative half, and again the positive half came into. So into this one period of cycle, we are getting only half time the positive output. So this is basically a half bridge rectifier, and during whenever there is negative cycle, there is no output voltage, zero. Similarly, when we come to this, so this is a half bridge rectifier and this is a full bridge rectifier. So onto the screen, you can see that when we talk about the DC, so the output DC, the requirement should be like this much constant value. The DC is this one, but we are getting pulsating. So what we do, we go for using the filters, like different LC combination filters are being used to get the desired DC voltage. Like there will be harmonics present, but like if you talk about the harmonics, so here we are getting lots of harmonics. If we compare this signal and this signal, then we are getting lots of harmonics. But when we use the filter circuit, then what will happen? The output voltage will be near about the DC, like a constant line, and then we can say that the harmonics is being reduced. Okay. So can anyone tell me like which harmonics is more dangerous from the participant?
No, lower order harmonic.
Odd harmonics. Particularly odd harmonics that too at the starting stage. At the third.
Lower order harmonics.
Yeah.
Third harmonic is more dangerous than all odd harmonics.
Basically, third harmonics is very much dangerous because it makes the circuit opaque.
Yeah.
So similarly, if we see about this full bridge rectifier, so when there is positive half cycle, so simply just refer to the sign convention, we can get the output. So when this is forward bias, so this switch will be on and this switch will be on, and during this time this switch will be not conducting. So when we this switch are on, so we can see the flow of current. So it will be flowing from here, and this will be the So this one will be how the current will be flowing and completing its path. So during this time we are getting the output voltage. Now when there is negative half cycle, so during negative half cycle, let me remove this. During negative half cycle, so this one and this one, this diode and this diode, these two diodes will be on, and then during that time we will be getting the output voltage. Even in the reverse, negative polarity, we will be getting the positive voltage. So this is how, because of the switching, like the switching configuration and switching technique, we are getting the DC output. So this is all about the rectifiers. Now we will be talking about the inverters. So basically inverters, you can see here, and like it has the DC supply. So whenever DC supply, because of this circuit combination, you can see onto the screen, there are anti-parallel diodes. Like this one is the thyristor and this one is the diode. So because of this switching configuration, we are getting like the input will be, in case of inverter, it will be DC. But in case of inverter, we want a DC supply, sorry, AC supply. So it now at what happens in inverter, and it is being configured as levels, like 1 level, 3 level, 5 level, 7 level, 9 level, and 11 level. So as much there will be the levels into this DC supply, there will be a fine curve, and that there will be reduced into the harmonics. Like in talking about the inverters, we are not able to remove the harmonics. There will be little bit harmonics will be present. But by increasing the levels, we can get the reduction into the harmonics. So this is, let's suppose when I talk about the level. So this is 1 level, 2 level, and 3 level. So this is the 3 level inverter. When we are getting the output in this manner, let's suppose we are getting the output in this level. Sorry, this level. Then 1, 2, 3, 4, 5. So this is the 5 level inverter. So 5 level inverter will be getting by cascading the 2 inverters. Like you can see when we talk about the working, when there is a positive supply, so depending upon that, the forward bias condition is being there. And the same things, like as we did into the rectifiers, there will be the flow of current towards the load, and we'll be getting the required output. So this is about the inverter. Now we talk about the choppers. So basically choppers used for DC to DC conversion. So let's suppose here we have a boost converter. So boost, from the name you can see it, you can say that whenever we want to increase the voltage level, like at the input we have 12 volt and we want a 48 volt at the output, we will be using a boost converter. So depending upon this switching sequence, like switching, like we connect the circuit according to this, like L S and D. So this is inductor, switch and diode. We are getting the boost converter, like the input voltage will be lower as compared to the output voltage. And now when we talk about the buck boost converter, so depending upon the switching frequency, duty ratio, like whatever will be the duty ratio, this converter mainly act as a bidirectional, like the output voltage sometimes becomes higher as compared to the input, and also sometimes the input voltage will become higher as compared to the output voltage. So it totally depend upon the duty ratio, like the D. So duty ratio is basically T on divided by T total. So this is the total time period of the switch. So these are the switches, the switching frequency, also the turning on and the turning off of these switches is responsible for the step up or the step down operation of these choppers. So these are the choppers. So this one is the boost converter. Just remember the circuit, like this is L, this is S, and this is D. And here into this chopper we have S, L and D. And talking about the buck converter, so we have here the switch, this is the D and this is the L. So depend whenever there is questions involved into solving this for circuits, like when we are turning on the switch, what happens when we are turning off the switch. So all these equations we solve and we get the desired output, talking about the buck converter, the boost converter and the buck boost converters. So I hope you are understood with this circuit, like of the buck converter, boost converter and the buck boost converter. Now can anyone tell me, like in buck converter, so it is basically a step down, and boost converter is a step up chopper. Yeah. So here at the input you can see we are giving here the DC supply. Here also this is a DC supply. Why we are not giving a AC supply into this chopper as well as chopper? Why we are not giving a AC supply? Yes, can anyone tell me?
Because.
Okay, so I reverse my question. Like we know that the transformers, so transformer also do step up operation and the step down operation. But why we used this boost converter, buck converter? Like we can get this step up as well as the step up down operation from this transformer. Why we are using our converters or a choppers?
Because transformers not work with a DC voltage because the frequency is 0.
Yeah. So into the talking about the transformer, so the AC supply is there, which has some frequency. So if there is no frequency given, like if we give the transformer a DC supply, then the transformer will not work. So that's why we for step up the level of voltage level of DC current, DC voltage, we are using choppers. So this is the difference between the transformer and the chopper. Talking about the chopper, it is being used for DC step up.
Sorry to interrupt. Can you please repeat that sentence once?
Which sentence?
About this difference between the transformers and these choppers.
Transformers are also used for step up and step down operation. So basically transformer use AC current, AC supply, which is having a frequency. If we give the transformer a DC supply, in DC there is no frequency present, so the transformer will not work. Okay. So
It's okay, but in chopper, how I can not give AC supply, please?
So it talk about the, if we didn't give a chopper a AC supply. Okay. So if you give the AC supply, then what will happen? Like we need to derive that. Like if we give a AC supply here, okay. So it will have some frequency, including positive half cycle and negative half cycle. So we are controlling
Sabko.
the circuit by this. We are controlling the circuit by switches. We are not. We are giving a constant. We are not giving a AC supply like for AC step up as well as the step down. We have we require a chopper because this switching, these switches are responsible for the switching of the AC.
Sir, sorry to interrupt you. Your voice is frequently breaking.
Yes, sir.
Yes, sir.
Yes, sir. Actually, I am not. We are not getting clearly you, sir. Please.
Oh, okay. Now is it clear?
Now it is clear, but after some time.
Okay, maybe due to some network issue.
No, it's
Yeah, maybe,
okay,
sir.
but not clear.
Your voice is
Now is
breaking.
it clear?
Okay.
So we are trying to control the switch like the chopper circuit through these switches. Like we didn't want to get it controlled by the power supply because when we are giving a DC supply here, so what will happen? We are getting giving a constant supply will be there available. But in case of rectifiers, what we have see there because of the like the positive half and the negative half, we are trying to control the circuit by the sequence of the supply itself. And we here at the converter or the chopper, this converter, sorry. At this chopper, we are trying to control the circuit by turning on and the turning off these switches.
No,
So-
but sir, here also the switch we are operating by using a PWM frequency only, right?
Yeah, PWM frequency.
Then here also frequency was there, right? As like transformers.
That is the switching frequency of the switches, not the
Correct.
supply.
Here also, I mean, what we are trying to control is nothing but that switch. How we are, I mean, the switch we are controlling by using of a PWM signal, I mean, on off.
Yeah.
What actually the switch was doing is nothing but when the voltage is supposed to be applied and when the voltage is supposed to be off. That only it was deciding, right?
Yeah, no, the switching sequence, like when, like there is a complete derivation of like when we are turning on and the turning off. Because of that derivation, like when the turning on is there, then the equations will be occurred, and because of that turning on and turning off, we are getting calculating the output voltage of this push converter as well as the choppers, these choppers. So we are trying to control the circuit by this switch itself.
Okay, sir.
There is charging and discharging is happening, right, sir?
Yes.
Like the charging and discharging is happening in this circuit, right?
No, like that is happening inside this inductor. Like inductor we are using, which is opposing the sudden current change in sudden current. Like whenever there will be a
So,
certain,
like,
yeah. So there the
Yeah,
charge,
whenever the MOSFET is turned on, the inductor is charging, right?
and when this MOSFET will turn off, then what will happen? This inductor will oppose the circuit, and then it will be again discharging by changing its polarity, and then during that time
Charging the capacitor.
yeah. So basically we are like here to step up and step down the voltage by using this chopper. So now let's come to the like the designing part onto the MATLAB. So we will be designing a buck converter. So buck converter, what does it do? It basically convert step up, step down, step down the voltage. So step down the voltage. So we'll try to implement this onto the MATLAB. So let's go to the MATLAB software. So this is the duty ratio for the chopper when we do the switching operation, like when we turn on the switch, when we turn off the switch, when we solve the circuit, and then we'll be getting these equations. So this is my duty ratio, which is the ratio of output voltage as well as the input voltage. And this is the value of inductor. So this is the inductor which we are using, and this is the capacitor which we are using here. So how we will be getting the required desired output? So we have, let's suppose I want to convert 48 volt to 24 volt. Okay. So from this part here, the 48 volt will be Vs, and this one will be V output. So this is the V output and this is the Vs. And I want this. So what will be the duty ratio? Yes, 0.5. It will be 0.5. Now we want a resistance value. So like as per the requirement, like suppose if you want to design this chopper for 100 watt. So what will the value of R? Can anyone tell me? Yes. I want to design a 100 watt chopper. At the output, I want the 24 volt. So just suggest me the value of what will be the value of R here. Yeah, under root of 100. Yeah, simply P is equal to V square R. When we in this under root nose, it will be 54 square divided by 100. So what will be the answer? 0.6 ohms. So the value of R we have calculated, which is 5.76 ohms. Now this is the F. So basically this is the switching frequency. So when we talk about the switching frequency, it will be for MOSFET, let's go for 40 kilo ohms. 30 kilo ohms, 30 kilo ohms. So basically we will be going for 40 kilo ohms. So
Kilohertz.
yeah. So we have here 40 kilohertz. Oh, sorry, yeah. So what is the value of L on C here? Can anyone calculate?
Sir, how we can get this 40 kilohertz?
Because when you go to, like if you buy a switch MOSFET now, that will have the switching frequency itself. The MOSFET have 20 kilohertz, 30 kilohertz, 40 kilohertz, depending upon what comes.
Whatever MOSFET we have selected, its frequency, according that we have to consider, right?
Yeah.
Okay.
Yeah. Yeah, just helps. We have R value D here. It is 0.5 and R is 5.76 and F we have this. So what is the value of L? Yeah, 0.36 microhenry. Micro or milli. That is the value of C. Plus 1.5 is divided by wait a minute. I forgot to mention. So there is a voltage ripple here, which is pre-assumed. So it is always like 0.05. So it is pre-assumed value, the voltage level. So it is forget here. Okay. Yeah. So whatever the value you have calculated, just divided by 0.05. Yes, 0.0217 micro or milli.
Milli. Micro, sir.
Yeah, micro. So it is 0.0217 micro. Farad.
Farad. Microfarad.
Yeah, is it right?
Yes, sir.
So we have calculated the value of L, C, and we have here the T, which is 0.5, and we have the value of R here, it is 5.76. Microfarad. Okay, so we have just remember these values. Now we'll go to the MATLAB software. So this is the MATLAB. You can see here the command window. So it is used to give the command, and this is where the workspace, like whichever the value, let's suppose I give here x is equal to 4. So it will be so that I have created a variable which is having a value 4. So this is MATLAB command and script. Now we'll go to this Simulink because we are going to design the circuit of this buck converter. Just opening the MATLAB software. So here we can see the Simulink screen. Here we have library browser, and like whatever the components we want, it will be available here. So simply just go for, like when we see the circuit here, we have a DC voltage source, a MOSFET, a diode, a inductor, a capacitor, and a resistance. So we'll go to the library browser and find all this. So here simply write DC voltage source. So this is the DC. We got this. Now we will call for MOSFET. This is the MOSFET. Now we go for diode. So this is the diode. we will come here. So this is the diode. Yeah, this diode will be loading. Now after diode, we want in capacitor and resistors. So simply we'll go for series RLC branch. Here we will be talking as this value. Now we want to, we'll select here L, which will be giving me inductor. This one will be C here, and this one will be R. Yeah. So now we'll connect the circuit according to the circuit diagram. So here you can see switch, diode, inductor, capacitor, and resistance. So we'll get at it. We'll come to here. We have the resistor. Now we have designed the circuit. Now we'll start putting the value. So at the supply voltage we want 40 here, and at the output we want 24. So according to that we'll start putting the value of inductance. So inductance value, what was it? 0.036 millihenry, and capacitance it was 0.0217 micro farad. Now we'll have the resistance, it was 5.76. Now we'll give the pulse to this switch. So we'll call for pulse generator. What was the duty ratio? D, it was 0.5. So the pulse width will be of 50, like the 50%, and then we'll have the time period. So what was the switching frequency of the switch? It was 1 upon 40K. So time period is reversal of frequency. So simply we'll do 1 upon 40K. We have here the pulse. Now it will be connected to this switch. Now we have designed the circuit. Now I want to see the output. So we'll see for voltage measurement. Then we'll call for scope. Then we'll call for display. All the value. So let's run the circuit.
What MATLAB library did you use?
Yes.
What was the library and the Simulink you used?
I simply write down the component name, and then I connected the circuit diagram here.
So for this Simscape and Simulink was needed.
Sorry for interrupt, sir.
Yeah.
Is there any need to put some add-on, or it is just basic features?
That's basic, like I didn't use any advanced things, that's basic.
There is no need of any add-on.
No,
right?
no.
Okay.
Yeah, so I'm getting some error. So kindly check for the value of capacitance. I think it is wrong.
It will be picofarad. Let's try.
Yeah.
It is of the order of picofarad when I calculate it.
It is fine. So let me. Yeah. So basically, I think the capacitor's value I have inserted, it is wrong. So kindly do the calculation again so that we can get the right output, right answer.
Minus 12, can you try? E minus 12.
Yeah, it's showing minus curve because of this error into this. I think it is not showing the minus, it is actually showing the output DC itself, but there is huge ripple here. So I need to check for the value of this capacitor.
Is the direction of diode correct?
So diode is correct, sir.
Diode is unidirection.
Yes. Is anyone doing the calculation or?
Sir, just show me previous calculation once.
So capacitor value, can you put same in picofarad order, not microfarad? So E minus 6, put minus 12.
You are saying this?
Microfarad, yeah, picofarad.
10 to the power of 9.
No, it's not giving that exact value. So I think we have done some calculation mistake. Like we have taken here the time periods exact same. Everything is same. Okay. So kindly this value of L is also the same.
No, maybe you have to filter the output. No, you're not filtering the output.
I'm taking the output here. So let me calculate the value of C. I think C is some error because capacitor value, I think it's not correct. I'm getting this value, it's 21.7 minus 6. Yeah. So the C value was 21.7 microfarad. So you can see here at the output, the value which is here about 24 volts. So there is little bit ripples. So if we want to remove that ripples, we need to do some adding, like we have to add more filters to remove, to get exactly 24. So I hope you are understood about this simulation. So now the simulation has run. I run the simulation for 10 seconds. Now at the output, you can see I am getting the value which is near about 24. Like there are some ripples, but that is very much negligible. Like that is not too much of ripples. So you can see it is near about like 23.4 to 24.3. So there is one volt ripple is present coming there. So we can eliminate by changing the value of L, or else we can add an extra LC filter or RLC filter so that we can get the exact 24 volts. So that was all from my side. So any more questions if you want to ask, you can ask, or else we can just.
Okay, sir.
Okay. Thank you.
Thank you, sir.
Thank you very much, sir. Thank you.
Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you so much, sir.
Thank you.
The certificate. Hello.
Thank you, sir.
Thank you, sir. Very thank you.
Thank you, sir. Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you
so much, sir.
Feedback from link.
Thank you so much, sir.
Hello. Hi, everyone. So if you guys are having any question, you can ask it right here. And we will be sharing the feedback link in a chat box. So in the meantime, like we are having some products where you can learn more about the SolidWorks or the MATLAB or the more about the electric vehicle. So I'm just playing a video where you can see our products and the courses that we are having. If you guys want to enroll in these courses, you can enroll. So please go watch the video. I'm just sharing it right now.
You also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISIEINDIA has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, globally valid certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD, and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, AV machine cutout section workbench, two-wheeler, three-wheeler, four-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off-grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions, and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Yeah, so we are having multiple products for each and every students. Like for the wide domain of like we have a wide variety of the courses available for the students, for the working professionals, and for the dropouts, those who are looking for the jobs. Apart from that, we have a solution for the hands-on training, like for the colleges where like we are setting up the center of excellences. So we are providing the course in a blended mode, which is in online plus the offline mode. So if a student wants to learn more about the EV, you guys can inquire regarding our courses, and like our counselors will get back to you. So if you guys are having any questions, you can ask it right now. So you can scan this QR code and like fill up the inquiry form. So those students, those who are interested, or the working professionals, or the students, those who are looking for the jobs, they can fill up the inquiry form. We will share the details of our courses, and then you can go ahead with the enrollment process. And our counselors will guide you what all